Okay, so we are now finished the topic of algebra, and so this is a algebra revision workbook, and I'm just going to go through and make sure that we have covered everything here, and this is going to act as a little video guide that's going to help you maybe with any questions that you might be unsure of. The beginning, the first page is on collecting like terms. Okay, if I just work down the right hand column, please remember that when you have 4a and you add it to 3a, together you get 7a for that. Okay, the next one, 5y plus y, is simply 6y. Okay, what you're doing here is you're collecting the like terms, so you're just taking the 5y and the y and you're bringing them together to give you 6y. Question 18. Y take away y in question 18 is simply nothing. Okay, so you can just write your answer as 0. Let's continue on now. So question 22, 8ab minus 3ba. If you recall, this is the same as 8ab minus 3ab, which simply gives you 5ab. Okay, ab is exactly the same as ba, because 3 times 6, for example, is the same as 6 times 3. Okay, when things are being multiplied, the order does not matter. Question 24, 2x minus 7x. Well, 2 take away 7 is minus 5, so 2x take away 7x is minus 5x. Question 26, x minus 6x is minus 5x. You get the idea. Let's move down now to question 34. You've got 4m plus 5m is equal to 9m, and you stop, and now you put the plus 4 back where it was. Question 38. You've got 2kp minus 5kp, and 2 minus 5 is minus 3, so you're going to write down minus 3kp, and the plus 2k, you put it back where it was. Okay, that's it for collecting like terms pretty much. I might do question 49 for you. Okay, if you have a look here, so you got 6xy. Actually, before I even do that, I might rewrite the question. Okay, don't forget here that plus and a minus next to each other make a minus. Okay, alright, now let's have a look. So you got 6xy minus 5xy. Okay, you're going to collect those two. You got the 10ab minus 11ab, you're going to collect those two. And then you've got the 2bc minus bc, you're going to collect those two. So let's have a look first. 6xy take away 5xy is simply xy. Now stop. 10ab minus 11ab is minus ab, and you stop. And 2bc minus bc is simply 1bc, or just bc, and you stop. And that is now complete. Okay. Back to the right hand column now, question 50. 3 times 2x is 6x. 8 times 2m is 16m. Question 60. A half times 10 times 10y. Well, a half times 10 is 5. A half times 10a. A half times 10 is 5, so 5a. Question 62. 1 over 5 times 15 is 3, so the answer is 3xy. Question 64, minus 2 times 5x is minus 10x. Question 80, 4m times minus 3n. These brackets aren't really doing anything, these brackets here, because inside the bracket you've only got one term. Okay, so 4 times minus 3 is minus 12, and then you put the mn back where it was. Over here, this is straightforward. Question 82, 3 times 2 is 6, and 6 times 1 is still 6, so 6xy. Question 88, minus 4 times minus 6 is 24, and then you've got x squared y. Question 90, when it comes to division, if you recall in class during our Zoom sessions, I did say whenever you get a division question to rewrite the question like this. Okay, 3pq over 3. And now that 3 cancels with that 3, and all you're left with is pq over 1. And anything over 1, you just rewrite it like this. The reason I recommend that you do this, I'm going to show you very clearly on the next question. If you try and do this question, most people write down 4. 2 divided by 8 is 4, but that's wrong. Let me show you why. 2xy over 8. Okay, that's what the question's asking. Now, divide this by 2 and get 1. Divide this by 2 and get 4. And the xy stays exactly where it is. So you can see the answer is actually xy over 4. Okay, not 4xy, it's xy over 4, big difference. By the way, you're allowed to write this as a quarter xy. That's not an issue, okay? Same thing. All right, same with the next few questions. Sometimes they give you the division questions written like this, and other times they actually write them in that format anyway. If you'd like me to look at 98, it's 21a squared b over 3a squared. Divide this by 3 and get 7. Divide this by 3 and get 1. Cancel the a squareds, and you're left with b up the top. So the answer is now 7b. Question 104. Divide, just using your regular fraction skills. Divide this by 2 and get 3. Divide this by 2 and get 5. And put the x back where it was. Okay, moving along now. X times, question 106. Write x times x using index notation. That's just x squared. Next one, y times y is just y cubed. Fairly straightforward stuff there. Now, if you recall in class, when you do q squared times q cubed, whenever you're multiplying, you add the powers. Okay? So these powers get added, that one there and that one there. Okay. Same thing with the next one, question 116. 4 times 2 is 8. Then you put the y back. And the only reason you're adding the powers, like in question in this one that we did, you're adding the powers because you've got the same base. That's called the base, and that's called the index. You got the same pronumeral. Okay. If someone said to you x squared times y cubed, you wouldn't add the powers here because the bases are different, right? You can't do that. You just write x squared y cubed. That's all you would do there. So back to question 116. 4 times 2 is 8. Then you write down the y, and now 3 plus the 9 is equal to 12. And so that's your final answer. When you're dividing x to the power 7 divided by x to the power 5, you subtract the indices. Okay? You're going to do this minus this. For those who are interested, let me show you why you do this. Let's say I rewrote this question as x to the power of 7 over x to the power of 5. And let's say I now wrote x to the power of 7 as that, 7 of them, okay? 1, 2, 3, 4, 5, 6, 7, okay? And let's say I wrote the x to the power 5 as like this. Now, because of your previous knowledge of division, cancel 1 with 1, 1 with 1, 1 with 1, 1 with 1, 1 with 1. You can see what you're left with. your final answer that you're going to be left with is simply up the top x squared. Okay. Now, instead of doing all of this working out for the questions, what you could do is simply just do 7 take away 5. That's what you could do, which gives you x squared. Okay, so now y to the power of 9 divided by y to the power of 6 is y to the power of 3. The next one, 6y to the power of 5 over y to the power of 1 is 6y to the power of 4. The next one, 36 a to the power of 6 b to the power of 5 all over a to the power of 1 and b to the power of 1. The 36 you leave untouched. Now remember what I said before, if you have a to the power of 6 up the top and a to the power of 1 divided by a to the power of 1, you do that power minus that power, okay? So that gives you a to the power of 5. And same thing with the b's, okay? You do that power minus that power. So b to the power of 4. So 36 a to the power of 5 b to the power of 4. (123) is a very nice question. Let's have a look at this one together. Divide this by 9 and get 4. Divide this by 9 and get 1. X to the power of 5 divided by x to the power of 5 is 1, so you just don't write anything. Now y to the power of 7 over y to the power of 6 leaves y to the power of 1 up the top. And z squared over z to the power of 1 leaves a z up the top. And that's your final answer. Now, question 124 is not something that we have learnt in class, and that is one of the main reasons I'm actually doing this video, okay? This is actually a very simple law. Whenever you see a pronumeral with a power inside a bracket and then another power outside, all you simply do is you write down x, and now you multiply the 3 and the 2 together. So x to the power of 6. You multiply, these are called indices, right? Each one is called an index, and together they're called indices. That's the pronumeral, okay? So you multiply the indices, basically. Okay, so let's go through a few of these. Question 125 is m to the power of 10. 126 is p to the power of 8. 127 is t to the power of 6. 128 is k to the power of 15. 129 is q to the power of 24. 130 is a to the power of 63. 131 is w to the power of 120. And you get the idea, okay? T to the power of 3, k to the power of 7, q to the power of 12. Now what happens when inside the bracket you've got a to the power of 2, b to the power of 3, then to the power of 5? Very simple. You follow the same rule. You write down a, and you do 2 times the 5, which is 10. Then you write down b, and you do 3 times the 5, which is 15. So the same rule applies regardless of how many different pronumerals are inside the bracket. Let me write you another question. A to the power of 2, b to the power of 3, c to the power of 9, x to the power of 4, or to the power of 3. Your answer is going to be and you're done. Okay. So these are all similar, okay? They're all very similar questions. I do want you to be careful when there's a number inside, like this one here. This is question 143. I do want you to be careful here, because people are tempted to do 2 times 2, and that is incorrect, because if you recall what I said earlier, we multiply the indices. So ask yourself, the number 2, what power could you put here? Well, 1, because 2 to the power of 1 is the same as 2, right? I could take the number 2 and I can write it as 2 to the power of 1. I can take the number 5 and write it as 5 to the power of 1. I can take the number 6 and write it as 6 to the power of 1. Now what we do, just like we did earlier, let me go back and show you, okay? Just like we did earlier, where's the ones where you had multiple things inside the brackets? Just like you did here, okay? You wrote down the A, and then you multiplied the indices. You wrote down the B, then you multiplied the indices. So if this A was a number, you would still write it down as the number. So what I do here now is I just write down the 2 and I focus on multiplying the indices. 1 times 2 is 2. I write down the x, and 3 times 2 is 6. Now 2 squared is 4. So 4x to the power of 6 is your answer. Alright, same thing with this one here. I'm going to rewrite that 3 as 3 to the power of 1. So now I write down 3. 1 times 2 is 2. I write down m. 6 times 2 is 12. So the answer is 9m to the power of 12. Most people get tempted to just take the 3 and multiply it by the 2, which is incorrect. Now, good news for you. You would have learned by now that in maths, anything multiplied by 0 is 0, and that's true. But did you know that anything to the power of 0 is actually 1? For example, in question 146, 2 to the power of 0 is 1. In question 147, 5 to the power of 0 is 1. In question 148, 9 to the power of 0 is 1. Even if I said to you x to the power of 0, it's 1. Y to the power of 0, it's 1. M to the power of 0, it's 1. Now in 149, I want you to be careful please and use common sense. You can see in 149, only the k is to the power of 0, not the 7. Really, based on your algebra skills by now, you should know that I can rewrite this question as 7 times k to the power of 0. Now, 7 times 1, because k to the power of 0 is 1, so the answer is 7. So please be careful, don't just see a 0 and start writing 1 everywhere, because you've got to use your previous algebra skills as well. Now sometimes you get given the question 7k and together they're to the power of 0. That's different. That answer there is 1 because this power of 0 is being applied to both of them because they're inside the bracket, which makes them one item. Okay. So question 150 is 12 times p to the power of 0, which is 12 times 1, which is 12. Question 151 is actually 1. Doesn't matter what's inside. Everything inside here is to the power of 0, so your answer is 1. Even question 152. Okay, you got the 8m cubed. The whole thing is to the power of 0, so that's going to equal to 1. Okay. The rest of this is just combining a lot of the different index laws that you already know. Now this page is on expanding brackets. We have done a fair bit on expanding brackets. I'll just remind you, I'll do question 172, this one over here. 2a times b is 2ab and you stop. And 2a times minus 3 is minus 6a and you stop. Question 174, you can rewrite it like this if you like. Okay. Now minus 1 times y is minus y and you stop. Or 1y, doesn't matter. And minus 1 times 1 is minus 1. Okay, and you're finished. Right guys, that's the end of my explanation of the revision workbook. You should be able to do this now quite competently. You've got 176 questions, plenty of practice. Algebra is the most important topic of all of high school mathematics, and perfect practice makes perfect. So the more questions you do, the better you get. Thank you very much.